A couple things I wanted to mention on the block here, guys. This is the 427 for the S10. So we've got the cylinders bored. One of the issues that you have with big block Chevrolets, and a lot of people skip this step, and that is if you look at the angle of the valves on a big block Chevy, what you end up having is you have a really big shrouding event that takes place here. One of the things you can do that's a really big benefit is you take a gasket that you're going to use and you lay it across here, and if you'll notice, the gasket is oddly shaped here. Now you can see what we did to the block. This was all a solid piece of cylinder here, and what happens is the valve comes in there, and it's especially a problem like we're putting big stainless valves in, so the valves are canted, so they come in basically, instead of coming down toward the cylinder like this, they basically come in at this angle. Well, if you don't unshroud this here and cut this out to the ring and notch the block there, the bigger valve that you put in is going to be horribly shrouded by the cylinder. Even some of the chamber is shrouded by the cylinder. So what I do is I spray the deck of the block with Dicam, and then I take and I scribe a line here right up to the firing ring. And it's always a really good idea to take and relieve that block, and you got to do quite a bit of relieving to get it off of there. And of course this block's, I've already bored and honed it, but I'm going to re-hone it just a cleanup hone to make sure that there's no burrs here. And I'm also still going to deck the block, so a little bit of this is going to go away because I'm going to deck it, even though I could leave it like that. But a very good idea to unshroud the valves. This makes a big difference in flow in these heads, especially when you got bigger valves like we have. So another thing is the oil return here. I went in and there's all kinds of flashing in here and stuff. I cleaned that up, and then there's a return here. You want to relieve that so that you can get oil draining to the front into the chain area, because this hole actually sits pretty high here, and this thing has to fill up with oil quite a bit. Well, you don't really want the lifter valley to fill up with oil because that causes windage on the cam. So this serves two purposes. Number one, it gives me a bunch of extra oiling for the chain for situations where you're running the motor hard. Plus it doesn't allow it gives this oil a much better chance to escape out of here rather than puddling up here and sitting on the cam or causing windage on the cam and the crank. So you want to open that up and give that oil a chance to run out of there rather than let it sit in the lifter valley. I don't really like the fact that big block Chevy has openings above the cam here. The ideal situation is to have the oil draining in the back and the front and not the center onto the cam, but that's the way GM designed it and that's what we're stuck with. But if you open this up, it helps dramatically with windage. Yeah, so I'm going to set this up and deck it. We're going to square deck it. In order to get my compression ratio, I have to take a specific amount off. So I'll get this set up, and I'll probably shoot a little video of this thing on the deck and talk to you about that. Okay guys, so just a little update here on the 427 S10 build. I just got done decking the block. So what we did is I have a fixture that goes down in there, and I indicate off of that. We started out at 0 on our indicator here, which is up here, and after the decking we shortened it up by 20 thousandths. So we took 20 thousandths off of each deck, and by my calculations that's going to put my compression ratio right where I want it to be, about 9.8 to 1 with the pistons I've got. So we got that accomplished. It turned out really nice. I did diminish my unshrouding a little bit here. As you deck the block, take material off, it kind of makes your unshrouding. So I'll probably put that head gasket back on and scribe the line and maybe sand these out right to the head gasket ring again, because unshrouding the block here is real critical for the flow of the heads on the big block Chevys. So, but yeah, it's looking good. I'm excited. We'll get it off the machine now that we've got the decking done, and we're gonna start prepping this thing for assembly. Okay, so before we get started on the 427 build, I just kind of want to show you what we got, some of the parts that we've gathered together for this engine. We've got our pistons and rings. Now the pistons are a Keith Black hyper-eutectic piston, and we bought the ones with the appropriate dome on them so we could get our 9.7 to 1 compression ratio. It is a moly coated skirt, and they're 60 over, and of course we've had these balanced, so you can see there's some machining marks on these from the balance shop, because all this stuff went through the balancing process. With our connecting rod, we decided to go with a Scat H-beam rod. Now this is just a standard length big block Chevy rod. They all have the same length rod, and we went with press fit pins. This isn't a real high horsepower deal, so we just decided to save a little bit of money since I have a rod heater. We just went with the semi-floater press fit pin, which is going to work just fine for this build. There's nothing wrong with it. If you don't want to spend the money to have these put together, you can get the full floating piston pins, 1200 horsepower rod, which we're not even going to be half of that with this motor, so I don't think we're going to break them. So that's the piston and rod assemblies that we chose. We also got an SFI approved balancer. Now we had the engine balance with the balance shop put the balancer on, but it is a neutral balance. The big block, the 427, is internally balanced, so there's no weights or anything on it. And then of course we have our SFI approved flex plate that we're going to use with our 700 R4. We went with a Clevite performance bearing, the appropriate size. The camshaft is a Howard's. I did a lot of research before I actually purchased this cam. It's a Howard's hydraulic roller. There's our hydraulic lifters, and we chose a cam that is appropriate for the flow of our heads. I did actually flow test the heads. I'll probably put that later in the video somewhere because I shot some video of that and kind of give you those flow numbers. But this cam is about 600 lift, and it's about 242 degrees of duration at 50 thousandths, so it's going to work really well. They do have a pretty radical idle, which is kind of what we were after because we're trying to build a street rod here. But I didn't buy it for the radical idle. I bought it because the power range, the RPM range, and the lift works really well with our heads. That's actually how you want to select the cam. It just turns out that the Rattler, it has tight lobe separation, which is going to work pretty good with the compression ratio we've got, and it's going to have a fairly healthy sounding idle. So that's turned out to be a really nice deal. I bought the whole cam kit from them. Now the other thing is we also got the double roller chain from Howard's. It came with the kit. We got they also in the kit sent us the thrust button. Now the thrust button is to locate the front of the roller cam. These early big blocks typically had from the factory, they had a flat tappet cam in them, so there wasn't any need to put any kind of a end play device on the cam because the lifters held the cam in place. With a roller lifter, you have to have a thrust button on the end of the cam, and when we assemble the motor, I'll show you that. Also, very important, you have to have a special timing cover to go along with that. This timing cover is specifically designed for that thrust button to butt up against. So you don't want to use the factory timing cover. They're too thin, and they have a tendency to move around. So you definitely got to upgrade your timing chain cover for that. We also got a mini starter for it, and these are We have, the push rods also came from Howard's. I don't have those. Those are over in the other shop. But the push rods, it's a hardened 7/16 push rod. And then, of course, we got a set of steel, full roller rockers that we bought from Speedmaster. I've used their stuff before, and they're pretty decent. I've had real good luck with them. So we're going to top it off with rollers. The intake manifold, we also got, there goes the box, we also got from Speedmaster, and we went with a dual plane setup because, you know, this is an air gap. It's like a medium rise air gap dual plane. I like these air gaps because you get cool air going under the carburetor. And we went with the dual plane setup. We did get a plenum that's raised a little bit because we wanted the RPM range to get up. The RPM range on this intake is about 2300, and they machined this out here to make it more of an open plenum type thing. Of course, it's still dual plane, right? Because the open plenum is just way too high of an RPM for what we're doing here. We want to drive this thing on the street. But this is a higher plenum. It has more plenum area here, and it has a cutout here. So the RPM range on this intake is about 2300 up to 6,000, which is perfect because our 427, I'm not going to rev it any higher than 6,000. That's where the cam RPM matches that. The cam RPM is about 2,500 to 6,500, so we're right in there, and it matches our head flow too. So I've done a lot of research to try and match these parts as good as I can. I think it's going to work really well. I've done a few of these builds in the past, and with the fully ported 781 heads, which the heads are sitting right back there, they're finished. I did some video shots of the heads. We flow test them, and the flow numbers are phenomenal. So with our flow numbers, we're expecting around 500 horsepower out of this engine, which is, you know, not that hard to do with a big block if you get the right parts combination. So again, it is a smaller cubic inch big block. It's a 427. It's not a 496 or anything, but I'm pretty confident that 500 horsepower is very doable with this engine. And that's about it. I mean, there's a few other things, of course, where I'm using a factory forged crank that I had prepped and balanced by 5-Star, the guys that did the balance work. They do a real nice job. And yeah, other than that, I've got the block all final washed, and we are basically ready to start assembling this baby. The only thing I don't have is I don't have a set of main bearings. For some reason, I bought the rod bearings for the balance job. For some reason, I overlooked the main bearings, but I can run down to EPW. They have them in stock, so I can get those. They're just right down the street. So I'm going to run down and get some main bearings, and we'll start putting this baby together. Okay, guys, so we've got our bearings now, and I choose to go with the Clevite H bearings. It's an 829H, and just be aware of the fact that these are expensive. It's a tri-metal bearing. It's a coated bearing. It's much higher quality than the stock ones. The main bearings will take as much as 2 tons force during a power stroke, and so when you got something that you're going to hammer on a little bit, it's always a good idea not to skimp on the bearings. You want to go with the good coated skirt bearings. Now the first thing we want to do is we want to check our clearances. So we're going to set these up one at a time, and we're going to install the bearings, and we're going to check our clearances. So we'll get our bearings installed into the block here, and then we'll check and make sure that our clearances are correct. The crankshaft has been cut or reground 10 thousandths undersized, and we have 10 under bearings. You want to take your whatever bearing you're starting with. In this case, we're going to do number 1. You want to take your upper bearing and put it in, and remember the upper bearing is the bearing with the groove and the hole in it. And then we are going to put the lower bearing into our main cap here. And make sure you get the right main cap. This is be number one. Main caps are location specific. And also be careful that you don't touch the face of this with your hand. You don't want to touch this. So we will install the bearing. Want to put a little bit of oil on those bolts. Put the bolts in. Make sure the arrow is facing the front of the engine. And then just go ahead and put your cap on. Once your cap is seated, you can torque it. We want to seat this cap here and make sure it's down flush, and you want to visually verify that it's down. And then we can go ahead, we're going to torque our cap in 3 steps. The next step is to mic your crank. I'm not going to do that on camera because I've already mic'd it out. And then we're going to set our dial bore gauge up so that it matches this. I have a lot of oil clearance videos on other builds that I've done, so I'm not going to spend a lot of time on that. Again, this video, I want to put the motor together on camera, but we're really focusing on the S10 build, so I'm not going to give a lot of intricate details about how to check clearances because I've already done that so many times in so many videos. If you actually want to see that and you can't find the video, just let me know in the comments below and I will post a copy and paste a video where I'm doing this. Okay, so we mic'd our crank, we set our bore gauge for our crank size, we got our cap torqued, and now we are going to look at the inside diameter here and see what our clearance is. My clearance is reading 3 thousandths. So I've got 3 thousandths oil clearance on the mains, which 2.5 to 3 is what the factory says, so it's perfect. Now, off camera, I'm going to go ahead and check all these. You want to verify every oil clearance that and make sure it's correct, and also mic your crank really good. The guys that prepped our crank at 5-star, I don't have a crank grinder or a balancer. 5-star here in Phoenix, they do a really good job of prepping our cranks for us and doing the balance jobs, and their cranks are dead on every time. I've never had any issues with their crankshaft grinding. So yeah, I'll get the clearances checked. Once we know that's right, then we'll go ahead and start putting this baby together. Okay guys, so we got all of our clearances checked, and we got the upper bearings in the block. And gosh dang it, I told this guy that recording. Let me shut this door. So we got all the upper bearings in, and we final washed our crankshaft. Another thing we want to do is we want to get the rear main seal in this thing. So before you lay the crank, and also I'm going to go ahead and put the camshaft in because it's a lot easier to access the cam without the crank in the way. So I'm gonna lube up that cam, and we'll go ahead and install our new Howard's roller cam in the engine. Sorry about the background noise. My buddy's messing around with his Camaro out there. All right, so we also don't want to put the cam in totally dry. We want to put some moly graphite on this gear here. This is really good stuff. I recommend you using it. You can buy this at Napa. We'll go ahead and put just a generous portion of moly graphite. Right on that gear. Now with a roller cam, you don't really need to use, if this was a flat tappet cam, I would be coating all these lobes with this stuff. With a roller cam, you don't really need to do that. In fact, I don't recommend it. I like to just use a heavy break-in oil on the lobes, because a thick assembly lube on the roller lifters actually causes the roller not to roll on here. It actually slides on here, and you don't want that. So we just want to put a good amount of assembly lube on that gear, because that's going to mesh with our distributor, and we definitely want to lube that up. And then as far as the lobes go here, we're just going to go ahead and use a good quality engine oil on each one of the lobes. You don't want to put this thing in dry, so just spread some engine oil onto those, and then you can install your cam. You also want to be very careful when installing this cam. You don't want to force it in or jam it in there, so we're just going to very gently, we've already test fit the cam into our bearings, and I'm not going to put any lube at this point on the lobes. I'll do that from up top when I put the lifters in, but these main cam journals here that ride in the block, you definitely want to lubricate those as you go in with this. So we're just going to very gently put this in, and we're going to get our last two lubed up here because I didn't get any on them. So we'll just go ahead and take some light engine oil, make sure these aren't dry, and then we very carefully install our cam. The key is to be gentle with this. You don't want to ding or damage any of those bearings. Now, the nice thing, like I said earlier, now that I've got the cam in, I have free access to it here. This is why I like to put the cam in first without the crank in my way, because otherwise you get a blind hole. And I leave the plug out of the back of the block, so I got my hand in the back plug back here, and I just kind of very gently guide the cam into the bearings, and there it is. It is in, got lube on it, and for now that's good enough on the cam. Now we can get this crankshaft installed in this baby. We got all our clearances checked, everything looks really good. We got the crankshaft final washed, and we are ready to rock and roll. Okay guys, so we got our crankshaft in, we got all the caps on, got them seated and got them torqued. The crankshaft's turning really nice, there's no binding. You should be able to turn this crank by hand. You shouldn't have to force it. You should be able to take one finger and rotate this crankshaft. One of the next things we're going to do is we're going to check crankshaft end play, and we're also going to put this gear on. Now, sometimes you'll get a gear that has multiple keyways on it. This one actually does. If you're running any kind of performance cam, what I recommend is you set it up based on straight up. In other words, you want the timing where it was from the factory. And in the case of this gear, there's a square, there's a triangle, and there's a circle. The triangle and the square are going to advance and retard the cam timing off of straight up. When you run a performance cam, you want to run this thing straight up, so we're going to use the circle mark. So we're going to use the keyway that has a circle above it, and that's going to put us straight up. So when you put it on, use the keyway with the circle. These gears are pressed on. I have a tube that I use to press this on. I'll go ahead and get this on, and then we'll stick an indicator on the back of this and see what kind of end play we got. We're also going to have to talk about this camshaft because we're going to have to set it up with the thrust button, and I'll show you how to do that. So when checking end play, guys, we want to set a dial indicator on the front of the crank or the back, whatever. This is one with a magnetic base, and then we want to pry the crank back and forth, and you'll be able to see the end play here. We have about 8 thousandths, which is really good for this crank, so that's exactly what we want to see. About 8 thousandths, and we are good to go. Okay guys, so we got the timing chain and gear set on here. I also got the thrust button in here. I did a lot of trimming on that thrust button off camera to get it exactly right, because on a roller cam you got to use something to control the end play of the cam here. I had to trim about 200 thousandths off of that thing in order to get it to work with our timing cover, but I've got all that set up right. We have about 7 or 8 thousandths cam end play now with the cover on, which is perfect. The next thing we're going to have to do is we need to degree the cam, but we're going to have to put our piston and rod assemblies, or at least our number one. This is our number one piston and rod assembly. At the very least we have to put this in. So I'm going to go ahead and get this in, and then we'll do the cam degree. Now before you put any piston and rod assemblies in, it's real critical that you clean these bores out. It's a good idea to take WD-40 and clean these bores before you do your actual installation of your pistons, and I'll show you why that's true. So I'm just going to spray some WD-40 in this cylinder. Take white paper towels. Don't use like expensive toilet paper or anything like that that has all the fluffies in it. You want to just use paper. So we're going to go in, and that's what we're looking at. So just from this sitting around and residual stuff left on the bore, you got to go in and wipe all that out until you get nothing on your paper towels except clean WD-40. And it usually takes 2 or 3 rounds of WD-40 on that cylinder to get it clean. Do it again. Put some more paper in there. Which is round 2. Round 2, this looks pretty good now on this one. Yeah, we got nothing but clean WD-40, so that's good. The block was actually pretty clean before we started. Now that we've got that cylinder cleaned, we can get our number 1 piston and rod assembly in this thing. I like to orientate the block this way. It just makes it a lot easier. And then take your crankshaft and put this crank throw over here at bottom dead center, all the way down. Total Seal recommends that you coat the rings with WD-40. I agree with them. So we're going to spray the skirts and the rings with WD-40. We've already checked the end gap. The end gap on these rings is about 19 thousandths, which is perfect for this engine. So I did that off camera. And we're going to take some oil. You don't really want to be stingy with your oil here on this bearing. So we're just going to take and coat that bearing with a good, this is actually break-in oil. And now we want to put, well, also it's important you want to make sure that your rings are staggered. So I got the gap on the second ring here along with this skirt, and then I'm going to take the gap on the other top ring and I'm going to put it opposite that. I'm going to stagger those rings, otherwise I could have blow-by. Tapered cone is probably the best way to go as far as ring compressor, but keep in mind you have to have a specific one for your bore size. Our bore size is 4.310, and that is exactly what this compressor is, 4.310. It's a 60 over 454, which makes it ironically 440 cubic inches. So we got a 440 big block Chevy here. So it'll be interesting when I tell people, when they ask me what size engine the S10 has, I'll say that's a 440. See how many of them think it's a Chrysler. Alright, the orientation of the piston itself is the bearing tang or notch here is going to go to the outside of the block, and the valve reliefs always go to the lifter valley, you guys, always. So we'll just very carefully slide this in, and once we get our skirts started here, we should be able to just tap this thing, and be aware that you want to hang on to your rod on the other end. You don't want to damage anything down there. So we'll take our handy dandy piston driver here, also known as a soft dead blow. And we just very simply set your compressor aside, drive that down. Now I'm being real careful on the lower end back here, making sure that I don't damage that crankshaft. Usually we use journal protectors, but these scat rods have bolts in them and I don't have a journal protector for it, so you just got to be careful. The other thing is you don't have rod studs sticking out that can damage that. So once you get that to that point, and then we're just going to look at the lower end here. This is our number 1 piston and rod assembly, and I orientated the block around so you could see it. ARP, these have ARP studs in them, and ARP highly recommends that you use this lube on the bolts, and I recommend it as well. It's a very good idea. It helps you get the correct torque on these. So we want to put this ARP lube on the threads, and make sure you get up under the cap screw here, right where it seats. You want to put a generous amount on there. And this stuff, it's okay to have it in here, it dissolves in oil. So let's do that to both of our bolts. And that is going to help us get the correct torque on these. Tensile strength is very high on these ARP bolts. Once you get that, of course, then we want to put some oil on there, just like we did on the other side. I like to hold this over the engine in case there's any residual. Just get some oil on that bearing. Make sure the whole thing's now coated. Now the bearing notch again is going to go to the outside of the block here, and it matches the notch here. So both notches are going to be on this side of the rod on the outside. Get your rod on there, get the bolts in, and these rods have dowel pins, locating dowels in the cap. So once you get your cap screws started, you can just take your soft hammer and you can just kind of seat that cap up there like so, and then you run your bolts down and torque them to specs. Not rocket science. Okay, so I'm going to get this torqued. Once I get this torqued, I'll come back. I'm going to go ahead and set up the degree wheel, and we want to look at our cam card on this, and we want to verify that the cam is in correctly and that it's the right cam. So I'll be right back, and we'll get the degree wheel set up on this thing. Okay guys, so our next order of business here is to degree the camshaft. So I've got the degree wheel set up, and the first thing we need to do, you notice I have a dial indicator on top of the piston. The first thing we need to do is we need to find our true top dead center on this piston. Now, true top dead center is when the piston is at the highest point of its travel and the rod is dead center in the middle of the piston. And the way that we do that is we set up our degree wheel with a pointer, and what we're going to do is you're just going to bring your degree wheel up to where it says 0 on top dead center here, and you want to get also TDC on the piston. So we want to go to the highest point of travel here on our piston, which is right there, and then of course we'll zero this. We want to be right on 0. Let me zoom in on this a little bit so hopefully you can see it a little bit better. Okay, so I want you to catch the top of the wheel here and the indicators. Now we also have an indicator on the cam lobe, but right now we don't need to use that. In order to make sure that this degree wheel is orientated correctly, in other words, my pointer needs to be right at TDC here on 0. when this piston is at exactly true top dead center. Now there's a little bit of movement on the wheel here, and you'll notice I can move the wheel a little bit, a few degrees one way or the other, and I'm really not moving much on my indicator. It's moving a little bit, but you could be off a degree or two with this on 0. So we have to fine tune that. So we're going to bring this up to the highest point of travel, or what we call approximate TDC here. And then we're going to go down in the bore 50 thousandths on our indicator. So we're going to go backwards, which is counterclockwise here. So we're going to turn our wheel counterclockwise. And we're going to watch our indicator. We're going to go down past the 50 thousandths mark. And then we're going to come right back to 50. Go past it a little bit when you go backwards in case there's any slack. Now what I'm seeing right here, guys, is that my indicator, if we look at it right there, is right on 12 degrees. Right? Let's make sure we get it right. It's right on 12 degrees, and I'm at 50 thousandths. Now I'm going to go clockwise. I'm coming back up to top dead center. And then as I rotate, the piston's going to start going down again. So there it goes. It's going down, and I'm going to go down right to 50 thousandths this time. When you're going forward, you don't need to go past the point. You can go right to it. So I'm right at 50. And now on the other side here, you see I have 12 degrees. I'm right at 12 degrees. So I have 12 degrees and 12 degrees. What that means is, when I come up to 0 here on my indicator, whoops, I'm going the wrong way. When I come right up to TDC, when that thing is zeroed out, right there, I'm on 0 here. That means that this mark, or this wheel, is orientated with exact true top dead center. And that's how you do it. So you need the same number of degrees on both sides of that. Let's say hypothetically you had 10 degrees here and 14 here. Then you would need to bend the needle a little bit to even that out, because what we're doing is we're locating the needle to the TDC mark here based on this, and that's how you do it. So there's also another method called piston stop, but I just found it's easier to use an indicator. Another thing we want to look at is we want to look at our deck clearance. Now, in an earlier video we talked about how that we set this up and we decked the block. We wanted to get the compression ratio to about 9.8 to 1, and we did the calculations and discovered we needed to have about 10 to 12 thousandths, somewhere in there, deck height. So the way that you check that is we're going to take our indicator here and we're going to zero it out. We're just going to go on a flat surface here. So we're going to put the indicator right at 0. And then of course when we put this indicator on the piston, that'll tell us how far down inside it is. It's because it sits down in the bore slightly. Now we have to get off of the dome here. So we got to be on the flat spot of the piston. So we want to go, let's see, we'll go right here. And we'll get on the flat spot of this piston. All right, right there. Now, I want to come up to the highest point of travel, which is where I'm at. So I'm going down there, I'm coming back up, and I know that 0 on my indicator is exactly square with the deck, and I am about 8 thousandths down below the deck here. So about 10 thousandths is what we were shooting for. 8 to 10 is good. So we got about 10 thousandths deck clearance. We had 30, and we took, of course, 20 thousandths off this block. So now we got about 8 thousandths. 8 to 10 thousandths is what we're finding. If we check another piston here, we can bring this one up and see if we can get on the flat spot here. See what we have on this one. We'll get over on this flat spot if we can, which is right there. And we'll come up to TDC. Now I'm hitting the piston here. this way. Right there, we're on the flat spot. Okay, right there, you guys can't see the indicator, but we're on the flat spot right there, and I have on my indicator exactly 8 thousandths deck clearance, same as this one, so that's a good indication. When we square deck it, we center the block up based on the crankshaft down here, and we deck this. And you want all these to be the same. And the first two are about 8 thousandths, and I know that it was square decked with the correct fixture, so I'm not anticipating any problems there. Okay, so now we have established our top dead center here. So that is our 0. Now at this point you want to make sure that you do not move that needle. Now at this point, I mean, you can leave this on here, but we're not really going to use this indicator anymore. Now we're switching over here to the indicator that is on the valve. Okay, so every camshaft comes with a cam card. This is our cam card for this this Howard's Big Daddy Rattler cam. And so what we have here, first thing we're going to do is look at our lift. We also want to check the timing events, but we want to make sure that we have the right cam first of all. So the gross lift on my intake says 353 thousandths. That's my lobe lift. Now the valve lift is much bigger than that, but my lobe lift is 353. So what we're going to do is we're going to get off of the lobe completely. So you want to go down to the lowest point of travel. Or in other words, when you're rotating the wheel, if this indicator is not moving, you see how it's not moving there? And I'm going to take and move this one back here because I don't want you to get confused. We're not worried about that right now. We're only on this cam lobe. So right now I'm turning the engine and this indicator is not moving. Let me see if I can zoom in on that just a little bit. So you can see this indicator is not moving. When this is not moving, you're on the base circle or you're off of the lobe. At that point, what you want to do is you want to zero out your indicator. You want to zero it out because this is going to measure our lifter rise over here. Now, according to the cam card, when we get onto the lifter with our gauge here, we should have 353 thousandths of lift. Okay, so we're verifying that this cam actually is what they say it is. So we're going to go until we start writing up the profile of that lobe. And there we go. So there's 100. Each rotation is 100 thousandths. There's 200. This is going to be 300. So there's 10, 20, 30, 40, 50, 1, 2, 3. Oh, look at that. Now it's starting to reverse. See, it's going back the other way. So that's my max lobe lift right there, and it is exactly 353 thousandths. Well, the card says that my lift is 353 thousandths on my intake. So that, we've just verified that that is correct. The cam card also says that my lift on my exhaust is 343, okay? So we're gonna put our indicator in here and we're gonna check that. So we're gonna make sure we're on the base circle, which we are, it's not moving. And then we're gonna go ahead and we're gonna zero the indicator. Same thing, and we should have 343 here. So let's go until we open that valve and we'll start counting. Okay, there it goes. So there's 100, 200, 300, 10, 20, 30, 40, 1, 2, 3, and it's reversing. So we got 343, and if you keep going, you can see we're going down the other side of the lobe. So that's our max lobe lift. The cam card says it should be 300 and actually 343 right there. Our exhaust lift is 343. That's exactly what we've got here. So that's a good indicator that this is the right cam. Now remember, you guys, sometimes it is possible that cams can be misboxed or they can be defective. This is a Howard's cam, and I've had really good luck with Howard's. There's some other name brand manufacturers where when you check the lift and stuff on them, they're off one way or another a few thousandths. One thing I've noticed with the Howard's cams is they are dead nuts on exactly what that card says. So their quality is really high on these. Okay, so I'm going to go back to the intake valve here, and I want to talk to you about our timing, engine timing. Now, the timing of the cam is important. That's actually the relationship between the cam and the crank, and I have some other videos talking about that. But the one spec that you're going to look for that tells you if your cam is timed correctly with the crankshaft is your intake lobe center line. If we look on our cam card here, it says that our intake lobe center line should be 103 degrees, right? It's 103 right there, intake lobe center line. Now, if the cam timing is off, if the relationship between the cam and the crank is off, that number is going to change. So the intake lobe center line, literally what it is what it's looking at when you measure it is it's telling you, look, when your piston is at top dead center, exact top dead center, your lifter is going to be, in this case, 103 degrees off of the center line of the lobe. Now, if it's more than 103 degrees off the center line, that means that your timing is wrong. Because really what we're doing is we're looking at the relationship between where the cam lobe is compared to where this piston is. So center line, or where the center line of the lobe is when this is at TDC, is going to tell you that. So the way that we check center line, there's a couple ways to do it, but this is the procedure that I like. So we know what our max lobe lift is. It was 353. So we're going to go all the way to the top of the lobe travel, the very top of the lobe travel, which is right there. That's the highest point of travel. So we're all the way up on the tip of the lobe, and then we're just going to zero out the indicator right there on the tip of the lobe. So right now we're at max lobe lift, and I've zeroed the indicator. And if you'll notice on the wheel here, it says, hey, here's your center line. Your center line is right in this area. So when you're on the tip of the lobe, you're on the center line of the lobe, and it says intake center line. But to actually get the exact center line here, we have to kind of do the same thing we did when we found true TDC on the piston. We're going to go backwards, which is counterclockwise, down past 50 on our indicator. So we're going to go backwards backwards past 50, and then we're going to go right back to it. When you go backwards, the reason you go backwards, the reason you go past it is because if there's any slack in the chain, you want to get rid of it. All right, so now we're going to take and we're going to look at the wheel. We're going to read the wheel. So we went down past 50, and we have 56 degrees. Okay, so we're just going to take 56 degrees. So we came 50 thousandths off of our center line here, and we'll get our calculator out here, and we're going to just document that reading. We're going to say 56 degrees. That's what we've got on our wheel. So we just document that number. Now we're going to go forward or clockwise, and we're going to go back up to the top of the center line. So we're going to come back over here to the center line. We're going to go right back up to 0. So we're in our center line area here. And then we're going to keep going, and we're going to go down to 50 on the other side of the lobe. And literally what you're doing here, this method, is it's fine-tuning, or it's pinpointing exactly where that center line is at based on 50 thousandths of travel on the other side. So now we're going to look at our wheel. We've gone down 50 on the other side, and we have 151 and a half. We'll say 151. So we had 54 on the other side plus 151 equals 205, right? Now, our center line is supposed to be 103. In order to get the correct center line, you have to take, because remember, we're measuring crankshaft rotation here, but the camshaft turns half the speed of the crank. So once you get this number, you have to divide it by 2 because the cam is only turning half as far. So we're going to say divided by 2 equals 102.5. Now our card says that our intake lobe center line is 103. So here's a rule of thumb, guys, when it comes to cam degreeing. If you're within a half a degree, it's considered dead on. Anything within a half a degree is good. Now if you're 1 degree off, then it's considered off. If it was 1 degree off, let's say it was 1 degree bigger, then it would be retarded. And if it was 1 degree smaller, say 101 degrees, it would be 1 degree advanced. But within a half a degree, so we're happy with that. All right, that shows us that our cam timing is set up right and this cam is going to perform as designed. Okay, now the next thing we want to look at is duration. We've established that the lift is correct, we've got true TDC, we've got our intake lobe center line. Now we're going to look at our duration. So our duration, and we have to use a spec for that, and we're going to use 50 thousandths because that's what's on the card. So our card says that our duration at 50 thousandths is 242 degrees of duration, actual duration, or duration at 50. So it should be 242 on the intake. Now the way that we check that is like this. Here's what we're going to do. So we're going to get onto the base circle of the cam, right? And duration, what duration is, you guys, literally is, if I had to explain it, duration is asking how many degrees does this crankshaft rotate while that valve is open. Now we can't do that from just anywhere on the base circle. If you look at that indicator right now, it's not moving, so I have to have a starting point. Well, down here I could start anywhere. I have no starting point, right? So the starting point that we're going to use is 50 thousandths. So we're going to get onto the base circle, which is where we're at, and we know that because our indicator is not moving, and then we're going to zero our indicator. Okay, we're just going to zero that guy. Now we're going to rotate the engine in normal rotation, which is clockwise, until we come up off of the base circle of the cam 50 thousandths. We're going to go up 50 thousandths of our lobe travel. And the reason we're doing 50 thousandths is because that's what they did here. When they checked it, they did it at 50 thousandths. So we want to duplicate what this card is, or see if we can, establish that the duration is correct. So we're going to come up off of the base circle 50 thousandths, just like they did on the cam card. So we'll get up to where our valve's open. Okay, there it goes. Our valve is opening. And we're going to go 20, 30, 40. We're going to go right to 50 thousandths. So right now I just came off of the base circle and I'm 50 thousandths up on my lobe. And then I'm going to read the wheel. So right now, if I look at my wheel, here's my top dead center. I have 19 degrees, right? I am sitting right at 19 degrees and I'm just on this side of top dead center. Okay, so now that's my starting point. So my starting point at 50 thousandths, my first number is 19 degrees here before top dead center. So then I'm going to go all the way up to the top of the lobe travel, and I'm going to go back down to the other side of the lobe travel, and guess where I'm going to stop? I'm going to stop at 50 thousandths before the valve closes. So I'm going from 50 on the opening side to 50 over the top of the lobe to 50 on the closing side, and I'm going to count how many degrees this wheel rotated from 50 on one side to 50 on the other. Okay, so we're at 50 thousandths now, and we know that our lift is 353. So there's 100. This is 200. This is 300. 3, 30, 40, 53 right there. So right now I'm at max lobe lift. I'm at the top of the travel, but I have to go back down the other side of the lobe, and I have to stop at 50 thousandths before the valve closes. So I'm going to count back down. So I'm going down the other side, there's 53, here's 1, this is 2, and so the valve, I got 100 thousandths to go before the valve closes, but I'm not going to go all the way. I'm going to go to 50 thousandths just before the valve closes, and now I'm going to read my wheel. Now remember, we had 19 degrees up here, okay? Now on this side, and when you do duration, you're doing the black numbers, right? So I have 19 degrees. Let's get our calculator here. I have 19 degrees before top dead center. And now over here I have, and you use the small black numbers for duration, I have 45 degrees after bottom dead center. So you got to understand, I went over 180 degrees, right? I went a half a turn, plus I went from bottom dead center to here, and from top dead center up to 19. So we have to take 19 plus 45, which is what we have here, but we have to add 180 in there because I went 180 degrees in addition to these two numbers. So we'll say plus 180 equals 244. Our duration on our intake, according to this, is 242.6. So that's really close. On the duration, it doesn't really affect the timing as much. This is off a little more than 1 degree, and that's really not that unusual. There's discrepancies in the chain, and there might be a few discrepancies here, and actually this is between 45 and 44, so we got about a half a degree there. So really we got about 243 and a half, which the card says 242.6. Yeah, so we're there. That is a good reading. So that's basically how you do your duration. So we have actually verified that this cam is exactly what Howard says it was, right? On duration, if you're within a degree or two, you're there. For Centerline, you don't want to be off more than a half degree, and we weren't. So this cam is dialed in, and it is going to perform exactly like they said it was. I'm happy with that. Everything so far looks really good. So hopefully that makes sense. I actually have a couple other videos where I go way more in depth with cam degreeing and kind of explain the steps a little better and show you some pictures and diagrams and stuff if you're interested. The 383 stroker build part 7, I really go in depth with cam degreeing. But yeah, I mean that's cam degreeing in a nutshell, and I'm very happy with the way this turned out. So we'll get this wheel off here and we will continue assembling this baby.